gentlemen, very good afternoon to all of you. I'm quite overwhelmed with the qualification of the panel that I have to manage. Notwithstanding, you know, we're living in very, very interesting times, and I must congratulate ETAuto for curating such a lovely program. The earlier sessions were very, very interesting. Let's see how we can add value, and we've been given to talk about leveraging software technology for design and manufacturing in the new era. Not that we haven't been using software. As an industry, we've been, I would like to believe, being on the cutting edge. Automotive has been, and when it comes to the products, we've been using 3D, we've been using CAD, for 3D modeling, for optimization, making complex components and whatnot, cost competitiveness, testing, validation, all of it. And when it comes to the shop floors, we've been doing CAMs, we've been doing robotics, now Industry 4.0 and the works. And of course, today, what we will delve upon is, with the future of the softwares the technologies, how we can make the entire value chain from products to the supply chain, everything so much more sustainable, make them even more competitive, and of course, make them more close to the customer. We talk so much about immersive technologies. I do not know who's immersed into what, whether it is the customer who's immersed into the technologies or the technologies are immersed into the customer. So, I will introduce my panelists as I come to them, but I'll begin with Dr. Tapan Sahoo. He's the ED of Engineering at MSIL. And why I said of you the first one is because Maruti Suzuki is, in some sense, it has defined the PV landscape in the country. And last 5 years, Dr. Sahoo, you would agree that the quality and the look, feel, everything of the PVs that run on Indian roads is substantially transformed. And how do you, as an engineer, see this transformation rolling out with the new age software that we're talking about? Share with us your perspective as to how we are transforming ourselves. Of course, I mean, do cite examples from MSIL, and now that the Toyota is also in your fold, yeah.
That's a different game altogether.
Nevertheless.
Let's leave that out. I think, first of all, I think fundamentally Indian PV industry has changed dramatically in the last 5 years. In terms of numbers, of course, it has grown almost 20-25% from 17-18 if you look at the numbers. But there has been a few philosophical change, pre-COVID and then post-COVID. Pre-COVID, of course, we had a lot of regulations which came up. Cost went up, and there was a little bit of demand, and then management of inventory, etc. However, post-COVID, we see a fundamental philosophical change in customers. And what's that? Today's customers, if you look at the philosophy which is changing, people are like YOLO. I don't know how many of you have heard the term YOLO. You only live once. So that's the philosophical change which has happened. So consumers are trying to, on one hand, save more, and on the other hand, spend more at the right time. So what we see that the younger generation may not be able, may not be inclined to buy a car at a very young age, but when he is able to afford it, he will buy a bigger car. So that's a fundamental shift which has happened in the last 5 years. So in that context, if you look at the share of SUVs, it has doubled in the last 5 years. The share of so-called perceived bigger cars, which is greater than 4 meters, it could be SUV, it could be MUV, it could be a sedan, also has doubled from 35% to almost 69%. So that's the change in terms of size. So people want a bigger car, better car. The second thing is premiumization. I think with advent of all the global social mega trends, which are like, talk about carbon neutrality or talk about urbanization or talk about the rising middle class, digitalization, that's also affecting the consumers. Consumers are today much more globally connected, and therefore the inclination or the desire to have better features and more digital and connected technology also is changing. And what we have done, I think, if you look at our portfolio in particular and in the portfolio in general for the industry, has also changed. I think you see all makers getting into SUV segments, Maruti included, and you see the lot of new features are coming in. Take for example connected. I think today the connected penetration in higher segment vehicles is as high as 40 to 50%. And going forward by 2025, probably we'll have more than 2 million vehicles, connected vehicles on the road. So the point is, we are now coming into a point or a threshold point where we can use connected technology for the betterment of the society, which is like, how do we improve safety with connected technology? How can we provide more customization or more additional features over there to the consumers? So these are the 3 or 4 fundamental changes that we have seen. And in terms of how the digital technology is shaping, I think fundamentally during COVID era also, I think it actually accelerated the use of digital technology for product development as well as evaluations. So in the starting from the concept stage or the design stage, use of AR, VR has become part of the game. I mean, when you could not do physical models to evaluate, you can always do a augmented reality VR model to check how the design looks like. So these are the changes which are happening in terms of product development.
Absolutely right. Ladies and gentlemen, I just wanted to tell you something very interesting about the panel that we have here. Typically, when you do a panel discussion, you share questions in advance, okay? We haven't done so. So whatever you're hearing is all spontaneous. I thought this was a technology panel and sort of let's go blind. So that's what we are. So please give a big round of applause to my panelists. They do not know what question is coming their way. So Raghavendra, you're next. So Raghavendra Vaidya, he is the MD and CEO of Daimler Trucks Innovation Center, and this is the largest innovation center of Daimler outside of Germany. We have 1,300 strong, technically skilled people here. Raghavendra, I'm going to ask you, picking up the thread from what Dr. Sahoo said, is that now transformation is a reality today in India as well. How do you see things panning out in terms of building up scalable, updatable, yet secure platforms? How do you how can we overcome these challenges or the challenges that are there as you envisage here?
See, the biggest challenge is the unknown. Right? We all have certain idea of how to create competitive products for the future. And if you ask the 5 different OEMs which are competing in the marketplace, they will more or less give you the same answer, right? So it's going from hardware to software in terms of innovation. It's about the ecosystem. It's about the logistics, and so on and on and on. And everywhere, the problems are more and more getting pushed to the software stack to be solved. Now, that's a direction that we are, let's just say, almost sure that will pan out. But beyond that, everything is a little bit of an unknown, right? Let's take, for example, how do you create more value for fleet owners? We are a commercial vehicle industry. So we have a fair idea how to do that. But do we know exactly the path to that? No. So the biggest challenge is the unknown, right? And the way to deal with that challenge is to be agile and the ability to pivot. I'm not saying take a U-turn, that's not possible, but pivot, right? Pivot in quick time and be able to see where it is headed. And who will win in the marketplace are the ones who are required to pivot less, because pivoting always is a cost. So I think that's the biggest challenge. And how do we tackle that is continuously assessing what's important for the customers, what's important for the fleets. Because if you look at commercial vehicles, nobody buys a truck because it's pretty. Nobody buys a truck because they want it. They buy it because they need it, right? So we have to continuously be in touch with them and see how do we provide more value using software. And this goes across the system, and spoke about connectivity. It's a big part of the future game. But even how do we develop products? When we go from diesel engines to zero-emission vehicles, it's a whole different area, right? The batteries come from somewhere, the power electronics comes from somewhere, and we put all of that together and we add software, and we think that that's where the differentiation lies, right? We strongly believe that, but that needs to be proven in the future. So I think from that standpoint, what we do is stay nimble, stay connected, and don't get stuck in something, right? So that has to be done, and the game is going to be of building scalable, large software platforms where the innovation happens in the software and not in the hardware, because the cycles are much more longer there.
Absolutely. Great. Wonderful. I think you said something very profound on the pivot point. I quite like that. And the pivot is the customer, right? Everything revolves around the customer. And sort of picking up on that thread of the customer, Debashish, I'm going to move on to you. Debashish Neogi is
I wanted to add something.
Oh, please, go ahead. So by the way, to all my
Sorry for
panelists,
interrupting.
please feel free to interject and add. I mean, don't disturb, but after one is finished, please feel free to add a comment should you have on a subject that I've asked. Yeah, please go ahead.
Yeah, thank you. So good afternoon, everybody. Appreciate having the opportunity to talk to all of you. I'd like to just add a couple of things on top of what Mr. Raghavendra said. The topic of software and in general and software-defined vehicles is something that I feel very strongly about. Just to set some sort of a baseline or a benchmark, right? In most modern high-tech cars today, there are in excess of 100 million lines of code. So 100 million lines of code, that is staggeringly large number. Just to give context to that number, that is more code than what is there in a modern aeroplane, as well as for the younger generation, more lines of code than in your popular social networking websites. So the topic of upgradability and scalability and security and all of that become even more important. Right. And I think over the sessions that we've had today and what we will have going forward, we will talk about what's driving all of this. But I think, in my opinion, for us to be successful as an industry in this, and I'm actually more bullish about the fact that software is going to eat up hardware. We are on that trend. It's happening. Software-defined vehicles are a reality. And I think there are 4 key things. There are many, many things, but I think there are 4 key things that we need to do in order for us to be successful. One is we need to collaborate as an industry. Yeah. So the automotive industry has historically been siloed for various reasons, whether it's the car manufacturers themselves, whether it's tier 1s like us, or whether it's anybody else who's part of the ecosystem. So I think unless we work together, it is not going to be successful, simply given the scope of what we are trying to do, right? The possibilities are endless. And without collaboration, I think we will all end up trying to solve the same problem independently, and we will partially be successful, fail, lose a lot of time and money in the process. So industry collaboration is extremely important, and for industry collaboration to happen, standardization is extremely important, right? So if we look at how we can build software in a much more modular way, talking about service-oriented architectures, plug-and-play kind of systems that will allow you to upgrade your capabilities over time, then it becomes extremely important that we define standards that allow all the partners involved to have a level playing field and then bring their products into that. The other thing is around dependence on hardware and vehicle itself, right? So as you're doing more and more software development, if you continue to maintain a proportionate amount of dependence on a vehicle or hardware, you're going to increase cost, as well as increase the overall time to development. So how do we do this with more emulation, simulation, maybe digital twin concept is super interesting in this area. And last but not least, I think is fundamentally software development in the automotive space has to transform completely from what it is today. So the old cycles of long requirements, long design, long development, long validation cycles, all of that has to change. I think go to market in 3 years is simply not an option anymore. We're talking about building and releasing features, in a day. How do we get better in that? How do we build more modular architectures? How do we integrate more automation into what we do? How do we have fully automated integration pipelines? The concept of continuous integration, delivery, deployment, all of these things are super important. So I don't think without these 4, and there are potentially more, and I'm happy to hear from others on what those are, I think those are the fundamental drivers that will determine how we move forward in a software-defined vehicle future.
So that's great, Nikhil. Thank you for value adding there. But maybe while we are on the thread of collaboration, I thought, how are you seeing the automotive industry encompass the non-ecosystem players or the non-traditional ecosystem players like the software developers who not traditionally the auto software guys or say the startups. So how are you guys handling that? How are you bringing them in? How are you enticing them? Or they're just seeing the opportunity and walking to you?
I think everybody sees the opportunity, Vinnie. I think it would be foolish not to recognize what's happening in the automotive industry and the opportunity it presents. That also certainly explains the flood of startups that are in this space. I think there are 2 fundamental things that are driving this, okay? One is, I think, just this whole EV revolution, right? So if you simplify it completely, and for a second, humor me, a car is nothing more than a large cell phone on wheels today.
Whatever.
And so
wheels or cell cars.
Sure. So if that is the case, then that opens up the playing field to tons of folks who are non-traditionally, who have not been automotive suppliers or partners or have not been part of the ecosystem. So that is one of the reasons why people are coming on board. You don't need to have had decades of experience in the automotive world. 2 is the understanding of this movement towards a software-defined vehicle where, let's say traditional software companies, your Apples, Googles of the world, are now so interested in this because the entire paradigm has changed, right? So how we think about, in-vehicle electronics is different. The other thing is the end consumer, right? We can't have such a long discussion without talking about them. Their expectations have completely changed, right? So they expect, the same kind of interaction that they have with their mobile phone when they sit in their car. The car has become essentially a third living space. There is home, there is work, and then there is car. So how does a consumer stay connected? How do they stay entertained? How do they stay informed in a car when they're actually driving? So this has also opened up a whole lot of opportunities for new players. Lastly, I think this concept of value chain itself is going away. I think it's becoming more a value network, where it's not like one supplier supplying into another supplier, supplying into another, and then a tier 1, and then into the OEM. But I think it is a partnership where everybody is working together to deliver, something really amazing.
Right. Wonderful. And thank you for bringing the customer back so I can go back to Neogi. So Debashish Neogi is the MD of Renault Nissan Technical Center in India. So am I correct? It's Renault Nissan Technical and Business Center. Business Center. And congratulations for being 15 years into India. I understand that you have 8,000 plus engineers and 2,600 of them on software. Yes. So I just want to understand with such a huge, strong technical team and with the technologies that we're talking about today, AI, ML, spatial computing, and quantum computing, how are you, or how do you see the industry being relevant to the consumer? Going back to the same concept of immersive technologies, I do not know who's immersed in what.
Very good question. So basically, as we all agree that customer is on the top of our thinking process. So it all starts with the customer, what does he wants? And how can you make his experience even better? So to make that happen, software is a key enabler. I will break it up into 3-4 portions. First is in the very development cycle, as Dr. Sahoo said, right from concept to production, we are using software everywhere. Whether it is the styling of the car where we have to use AR to go in detail and try to fix the A surface of the car for all the defects. So you use AR, you use big screens as big as 5 meters, and then there are screens which are broken down into 100 sub-screens to see every minute detail of the car when it is getting conceptualized. Then from there, you go to the product and process design. And now it is the days of collaboration. As we say, the collaboration is not only with outside partners, but collaboration within the various entities. So earlier it was engineering PLM. Now it is an enterprise PLM. So we saw the digital twin, which is bringing the product engineer, the process engineer, but also the purchasing guy, the costing guy, the after sales guy. And all of them are looking at one digital mockup. So it's like the digital continuity across the enterprise where there is a single source of truth. So imagine the big revolution in the process of car making. Everybody is looking in real time the same data. So you cannot go wrong because the process guy is seeing the same CAD and the 3D model. The product guy is also working. And then as he's updating based on the simulation where he's refining the designs, the process guy is also working. But the same data is available to the suppliers and the partners also at the same time. So they are also in the same process of designing their subcomponents or subparts. So there's a big revolution which is happening, which is reducing the time to market. So some of my colleagues said 3 years of car development is a reality. Really, because the Chinese are really behind us. I believe that they are doing it in 2 years and 2.5 years.
They're after us, not behind us.
They are behind our back, but they are before us. So what I'm trying to say that the digital twin is sort of a must. It has to be there to take all the actors of car making in the process. And then there is system and software. So system and software is getting merged. No longer hardware and software, they have to be synchronous to each other. And then model-based system design is the key. So from a commodity to a part-based approach, we are going to a system-based approach. So this is very key because if you are talking of bringing customer value, I think system approach is what is the key word in car development. So I would say that these software tools and techniques, whether it is digital twin or software-driven vehicle, is bringing a much more collaborative effort, point 1. Point 2, we are having a system approach. Point 3, the time to market is getting reduced. The quality of output is good. There is more modularity, as some of my panelists said. We are reusing parts. So the manufacturing guys has to assemble less number of parts. We are talking nowadays for an ICE car, 1,500 parts in the production line. And for a BEV car, 1,200 parts, thanks to the modularity concept. So I would say that software is really enabling us to bring products faster, with good quality, meeting customer expectations, and reducing the product development time and the cost to develop the cars.
Absolutely right. Yeah.
And of course, our ISIT team are enabling some deep tech like artificial intelligence to predict customer behavior. So in the morning, we had the discussion about data-driven engineering.
Right.
So how we can understand the customer better through real-life data analysis and feed it back into the design loop so that we can make cars suited to the customer.
Wonderful.
I think software is everywhere.
Yeah, yeah, yeah. Azmathullah, I'll come to you. Don't get a little edgy. I'll come to you in the last. There's a reason for that.
No problem.
Okay. But Nikhil, coming to you, HARMAN has been doing some exceptional work, digital cockpit and whatnot, and a lot of OTAs happening there. There's a huge risk on security. How do you sort of look at the challenge in that space, and how do we address it?
Yeah, so I think we spoke about all of the good stuff associated with software, but I think there is, like with anything else, right? There are certain challenges, and security is probably one of the biggest ones out there. So in the past, right, your cars were largely isolated. They were not connected to anything else. So security was much simpler. It was sort of guaranteed by design. In order to break into, it was, you compromised on various other cool features, but you had a safe system. If somebody had to break into or hack your system, they had to actually get into the car, sit, somehow connect to the back-end network of the car, and then there is potentially the opportunity for something malicious to happen. I'd like to cite an example of what happened a few years ago, where there were people who were sitting in their home garage somewhere else. They were able to hack into the network of a car on the road and send messages over the air into the car that would then turn the steering wheel of the car, make the car stop. So you can imagine of course they weren't doing it for to cause harm to the people. They were doing it to prove a point, right? That the system is not secure and safe. So now we're talking about a situation where it is not just enough to have embedded security within the vehicle. Of course you need to have that. So in case somebody gets into the car, they are still not able to exploit its vulnerabilities. But we're also talking about security when it comes to network traffic. So cybersecurity on the network. We're talking about security off-board in the cloud, where if you're talking about connected, personalized solutions where we are assuming a lot of data and input from the user has to be collected and manipulated in order to build more personalized solutions, then that data is potentially available on a server somewhere for somebody to steal. And in the previous session, people were talking about, in my opinion, the oil or gold of the future is data. So that is the most valuable commodity. So all of these things need to be secured, and there are technical solutions for each and every one of them. And there's not enough time to talk about all of them, but I think a general comment in that space, right? Today, security has to become part of everything we do right from the beginning. So when we're talking about requirements or when we're talking about architecture, security has to be baked into that and start from there. Only then can we build, because not only are our systems becoming smarter, our hackers are also becoming just as smart.
Absolutely. Very recently, I was in Israel 2 weeks ago, and we met an ethical hacker. And this gentleman bought an ECU of a car on eBay. What do you call those, the hot guns, he used to extract the chip out of the ECU. And he showed us the entire data, the phone book of the owner, the routes that he had traveled in the history that the chip had. He used the chip to hack into the servers of the company. He had, lo and behold, everything. So please be careful when you dispose of your old phones or your old computers. There is a lot of data sitting in there that you are unaware of. And of course, when you dispose of your new smart cars, there'll be another challenge for you too. Nevertheless, coming to the guy who's at the back end and giving us all the softwares, introducing Azmathullah Mohammed, the business director of Dassault System India. And I think everybody is aware of your 3D experiences, 3D experience platform, if you call it. Very simple question to you is, from a software perspective, what does the future hold for you? What are you guys working on?
Yeah, before getting into the future, I just want to derive out of the statement that you that you started off with initially, saying that as far as software is concerned, in the context of product design and development, people have been using CAD, CAE, CAM, and all that. And and when we talk about this advancements that are happening in this field and how this digital twins are really shaping out, the primary point that I want to make, and also an extension to what Mr. Neogi said, that the fundamental objective out of this digital twin is to ensure that all these softwares and the tools that we are using as part of the product development, be it on the design side or the simulation side and manufacturing side, or even on the supply network, how all of them can come onto one single data model or the platform. That's where I think Mr. Neogi has rightly highlighted the single source of data concept. I think I feel the fundamental aspect here is to have a unified data model approach, to have a single source of data which can cut across all these domains. Then the future that we look at out of this is how this particular data be leveraged in terms of achieving the objectives that every organization, every OEM is setting forth. Okay, if I touch upon some of the points, point number one could be the data integration. Now with the digital twin and virtual twin concepts, I think we are able to look at how the real life data can be brought in and can be simulated against the virtual data. And that will help you in having the right decision making. Second could be primarily in the context of the sustainability aspect that we are looking at. That is one of the key future aspect that every company is looking forward to. If I look at the sustainability aspect, one of the example could be the energy management that we are trying to do today. If I look at the hybrid and electric cars, okay, now the software is helping to assess the energy utilization and look at what are the possibilities to optimize the energy utilization, by which you are contributing to the saving and also to the green quotient and the green mobility objectives that we have. And the third aspect could be, what are the improvements that we can bring in the overall product development life cycle? I think, again, to drive out the point, from engineering life cycle to the enterprise life cycle, the point here is, in the beginning itself, while you are in the design stage, how we understand and how do we bring in all the different aspects associated with product validation and manufacturing. Somebody today in the morning, they said that the simulation data model comes much ahead of the design data model, the design data. So that also becomes one of the critical aspect. Okay, so in which your design cycle or design loops get updated in a way that you will have all the simulation, virtual validation, and manufacturing dependencies well assessed in the beginning itself. So to achieve all these, you need to have the right software solutions and tools which will give you, to repeat, the single source of data, and you can have all the data integrated compared to the real life cycle, which is real life data, which is the virtual twin of it. And also third is to ensure that the data is well leveraged for your decision making. So if you have all these things, I think that's the real future for this software driven.
Wonderful. Thank you. Thank you so much. The screen says my time is up. Would you allow me 2 questions from the audience? Is it allowed? Yes or no? 2 questions? Very quickly, I'm running very fine on time. Please introduce yourself and point out to who you wish to ask the question.
Hi, good afternoon. My name is Priyesh Mehta. I'm the director at Imaginarium. So quick question, I think it's open to all of the panelists. Do you think that manufacturing processes for automotive are increasing at the same speed as the designing tools? So simple question. I'll keep it short. Thank you.
Yeah, any of you, go ahead.
Can you clarify what do you mean by increasing? What I couldn't get.
So there is a lot of development and evolution of design methods, right? In the past decade, we've seen generative design, we've seen, a lot of optimization techniques of current, design methods. But do you, in your opinion, do you feel that manufacturing processes or methods have also evolved at the same speed to realize those kind of designs?
Difficult to say same or not, but definitely, I mean, when the product design is being done, it is being done in consultation with the manufacturing, right? What's feasible, what could be made feasible? What's possible today, what could be made possible tomorrow? So, for example, the shift from IC to EV requires a different kind of manufacturing technology. I mean, you'll require a lot more of high tensile steels, a lot more platform level changes, a lot more different kind of welding techniques which will be required for the BIW itself and for assembly of battery, etc. You need a lot more different technology. And all that is being done simultaneously while the product development is also evolving. I mean,
just to complement, as I said, product and process has to work together. So, lot of simulation tools are used. It has gone at the same pace. That means if you have to find the robotic path or design the stamping or the flow of the, so we call it as virtual commissioning. So you're able to literally virtually check the commissioning of the plant before you go live. Another thing is there is a lot of software in the plant itself. So you need to do hill. Now we associate hardware in the loop for product, but there is a hardware in the loop for manufacturing. That means you simulate some of the situation in the plant and see how the plant will react. So these things are also happening on the process side. So both are going hand in hand. You cannot say one is lagging and another is ahead of it.
That's true. Whatever we design eventually should be pragmatic and practical to produce. So, yeah, go ahead.
Yeah, well, one area where design and manufacturing could be a little out of sync is when you have a low volume, high variant design, which is manufactured to order, right? That is where I think manufacturing is still lagging because design can create variants and variants because that's what the market wants. But when you try to manufacture that, it becomes a little bit more difficult to drive efficiency. I think that is one area where it is lagging. Does anybody have a solution? I don't know if anyone has a solution. We'd love to talk to them. But that's one area which still needs more work.
Wonderful. Yes, please go ahead.
Hello. Yeah, thanks. Excellent panel. Lots of interesting information. So I have a question not related to this topic, right, because of a very good executive panel here. Given the software advent in whole passenger vehicle, commercial vehicle, mobility itself, is it a challenge for different OEMs or tier ones for product differentiation, right, compared to?
It's a huge challenge. And here is why. If you look at the last 60, 80 years of IC engines, the main differentiator, not the only, the main differentiator is the powertrain, right? The engines that we made, which has to comply to the standards and which has to compete in the market for fuel efficiency and so on. And that was a huge differentiator. Now, if you go to battery electric, hydrogen-based, it's an ecosystem, right? I don't think there is any manufacturer who goes from mining the rare earth material all the way to making a truck. It's not going to happen. So how do we differentiate the products when the hardware difference between two trucks or two cars is coming down? And that's where we truly believe software is the differentiator, right? And that's all we know. How and where and when, it's an evolution that we're trying to discover. But this, I think, is the biggest thing. Apart from that, of course, customer loyalty, your logistics, your after sales, all of that is there. But purely from a product standpoint, differentiator is going to be a huge challenge for OEMs.
Yeah, if I can add, I agree with what was just said, but I look at it slightly differently, right? The differentiator is not what traditionally used to differentiate two automobiles. It's not different from what's happened with your mobile phones, right? You are not able to differentiate between two mobile phones just based on how well I can talk to you, which was the primary differentiator. But I think the other way to look at it is that it presents a tremendous opportunity to everybody else, and which is what is, in my opinion, driving the interest in the automotive field today. That is true with non-traditional automotive software powerhouses of the world, you know which they are. But it also, I think, has an appeal to everybody, anybody in this room, right? So you could potentially now write the next application that can be downloaded on somebody's car and run within their you know, as part of their commute. So this lack of differentiation on traditional terms is creating tons of opportunities, and I think it has sparked tremendous amount of innovation, and we could have a full another full session talking about what all that innovation is, and we have quite a long list of that as well, but maybe side conversation.
Meet for the next ETAuto conference. So, ladies and gentlemen, I'm not sure I can conclude this session because there is so much more to talk about, but let me once again thank all my eminent panelists for spending time and for ETAuto for inviting us and hosting us.